Well, I'm excited to be on location at Venture Lab with the co-founder of Blumind, Niraj Mathur. Welcome.
Thanks. Great. Thank you for having me here, Justin.
Absolutely. Niraj has a storied history within our industry of spanning over 2 decades of contributions in AI accelerators, high-speed data networking chips, and or high-speed silicon IPs. And your contributions cannot be overstated. So I couldn't be more excited to be speaking with you today. First and foremost, tell us a little bit about what you guys are doing there at Blumind.
Blumind was born out of the realization that the path we're on for AI machine learning deployments is simply unsustainable. Okay, and we're quickly reaching a point where AI risks becoming undemocratic, too expensive, and too inefficient to continue using to its full potential. So Blumind was born out of the need to make AI actually far more efficient than it is today, and do this in a way that guarantees sustainable long-term deployment of AI in a multitude of applications.
You know my heart well, and democratization of AI is incredibly important. Why do you find that to be an important element?
It's a massive risk for humanity, actually, if AI becomes the domain of the powerful and the rich. It's really a tool that can solve many problems around the world for humanity and the planet at large. So it's really crucial that it remains accessible and effective for everyone to use. So this is something we feel very strongly about at Blumind, and really is driving everything that we do today.
I'm going to get back into Blumind a little bit, but while we're talking more global and at a higher level, are there any advancements or changes happening within AI in the next couple of years that you see coming around the corner that no one else does?
I think one of the big things, I wouldn't say no one else does, there's a lot of activity here, there's a lot of smart people working on AI, but one of the big things I see happening is this first wave of deployments in AI have really been focused around the data center, right? There's training and inferencing as well. A large portion of it is actually happening in data centers today, in servers, and with devices at the edge sending information up to the cloud to perform these operations. And while this is a good approach for many different applications and will remain to be so, there's a growing need for having more AI pushed out to the device. Okay, and a great example of this is robotics, right? You want to have autonomous robotic devices in industry, in our homes, in our lives, that can process sensory information or of their environment and make decisions right there on device with very low latencies, very low power consumption, etc., right? For them to be truly useful and reliable devices for all of us. So I feel that is one trend that is going to accelerate over the next decade, is pushing out more of this intelligent for those types of latency, power, and performance sensitive applications.
What's driving the need for that?
More and more folks are automating things in our lives, right? So you see many companies propping up now, building humanoid form factor robots that can do household tasks that we do in our daily lives more efficiently than us. You see assembly line robots that are doing, manufacturing all kinds of things way more efficiently than humans can, and in a much safer way as well. So the need is definitely there, and as more and more people see the capabilities coming online, this is just going to grow exponentially.
Ever since the first time we talked, I could tell that you're a product guy,
right?
But you're an engineer at heart. So
Yep.
you got your bachelor's degree at McGill University in computer engineering, and then how much later was it that you got your MBA?
It was around the time I shifted my career a bit from being a hands-on engineer and engineer leader to more understanding the business side of things, understanding what drives the need for this great engineering, right? That was very fascinating to me, and I wanted to understand more of that. So that's when I decided to pursue an MBA, and got that in About eight odd years into my career.
So after Nortel, you went to Quake, and then Quake was acquired by AMCC.
Correct.
Then Gennum was then acquired by Semtech.
Well, actually, yes, it's interesting following this family tree of companies and acquisitions, which are very common in our industry. But yeah, after AMCC, I left to join a startup called Snowbush Microelectronics here in Toronto.
Yep.
And that's what brought me to Toronto. Toronto has a great pedigree of high-speed networking, IP and product. So Snowbush was one of the pioneers in the space. Soon after I joined Snowbush, however, it was acquired by Gennum. Gennum was, I think, the last publicly traded semiconductor company in Canada. So spent a few years at Gennum. Gennum got acquired in whole by Semtech, which is a Southern California-based company. And then we decided that to carve out my division at Semtech, and that was acquired by Rambus. So that's how I ended up at Rambus. And that was kind of my last corporate gig, was VP of Marketing at Rambus.
So was that progression of startup getting acquired, was that part of the thing that lit that fire or that bug that bit you from an entrepreneurial standpoint? Did you know at that point you wanted to start your own company at some point?
Yeah, it certainly was a factor, but you know, I don't know. You know, everyone has his or her own journey here. Mine was more, I call it the curse of the entrepreneur. I kind of came to this realization that, you know, especially after doing my first startup, I was one of the early employees there, that, hey, I really want to build something and be part of going from 0 to 1, right? And so I just got bitten by that bug. I pursued my business education, and it was, you know, of course, life happens as well. I started a family and so on. So some of those aspirations had to be put on hold for a little bit, but I came back to it because I just couldn't. I didn't know what else to do, really. So when the timing was right and I had the support of my wife, we decided, okay, now's the time to make a go at it, and decided to take the plunge into Blumind.
You had to at some point decide Blumind was it. Tell me the story. How did Blumind start, and why was this the one that you wanted to put your chips in the middle of the table for?
Yeah, that's an interesting one. So, like I said, I ended up in the marketing team at Rambus, and it was really interesting. I was working on high-speed connectivity, IP, and products for data center applications, and the need for higher and higher connectivity was skyrocketing, right? We were getting customers that wanted to go from 100 to 200 to 400 to 800 gigabits per second for inter-data center links, right? So I was scratching my head about this, and I talked to some of my customer base, hey, what's driving this, right? Is the internet really getting that much faster? And the answer was no, it's not. It's actually not the internet. It's the processing and data movement inside the data center, inside the server rack or row of servers. That's what's driving this. And by the way, the use cases driving this are high performance compute and this new thing called machine learning, which consumes a ton of data, and that data has to move between storage and compute and back and forth, and between various compute elements as well. So that's what got me thinking. I was like, okay, what is this machine learning thing? I really didn't know much about it at the time. And I dug into it a little bit more, and I came to the realization that really the next level of innovation in semiconductors is going to happen because of this new use case, this new application space. And everything the whole semiconductor industry had been doing up to that point is going to fall short of the need for this new use case, these neural networks. Because everything up to that point was developed for human-written sequential code, and we had spent decades, the whole semiconductor machine, the whole industry had configured itself to meet the needs of those applications. And this is a completely different beast. So that's what got me really interested, and started looking around for opportunities for collaboration and getting something off the ground in this space. And that's when I met my co-founder, John Gosson, who's really a physicist at heart, but has this very amazing blend of device physics, analog mixed signal design, and machine learning data science. These three disciplines rarely come together in the same company, let alone the same individual. So John, I met him under a completely different context in 2019. And when he talked to me about his real passion, right? We talked about this other thing we were supposed to talk about for a bit, but then he moved very quickly to his real passion, which was this ultra low power compute. And he very clearly saw this huge barrier that we were marching towards, this wall of efficiency that would just severely hinder the deployment of AI. And talk to me more importantly about what he's going to do about it, right? What his solution was that he had been imagining and working on in his spare time over the last few years. And when he shared that with me, I was pretty much instantly convinced that this is the answer. We've got to move away from the 75-year-old von Neumann compute architecture to something else that's going to be far more efficient and guarantee the proliferation of AI while being mass producible and low cost, right?
You led us to kind of the proverbial elephant in the room.
Right.
Your solution then is centered around analog compute.
Yep.
All right, and so that's contrarian to what a lot of people are doing. Tell us why.
It is, and we struggle with this, Justin, because we don't actually even think of what we do as compute. It's really it's something we've struggled with, and it's something we've struggled communicating to other people that are so entrenched in the old paradigms, right? We fundamentally see neural networks as a different problem altogether from compute. Okay, it's more a signal processing problem rather than a compute problem. A compute problem, computers imply you've got program memory, you've got data memory, you've got ALUs, arithmetic units, you have a compiled instruction set that then runs on these arithmetic units and coordinates, orchestrates the data movement between all these memories, right? And that's what compute is. That's how all our cell phones and computers and everything else runs. And what the industry has done is tried to shoehorn neural networks, which are fundamentally not that, into this architecture. And that's what's led to all these inefficiencies. We imagine neural networks much like our brains as being a signal, our brains are biochemical signal processors, and that's what neural networks ideally are for them to realize the best level of efficiency. So we have modeled our architecture more around that model rather than the digital compute, von Neumann compute model. So it's something we're still refining. What our messaging, how do we communicate this to people, and how do we get people to understand why is it different and why is it important? We're still refining that. But what I must say is over the last 6 months to a year, we've seen more and more people warming up to this idea and seeking alternatives because they've hit that wall in their application. They just cannot do machine learning with the efficiency that they really need to make their application work. So they're coming to us and saying, hey, tell me more about what you guys are doing because we like what you're talking about. We want to understand it. So I see that change now starting to happen, and I only see that awareness growing going forward.
Curious, why the name Blumind?
Interesting. So, there's a few stories behind it, but I'll say the one I like. It reflects what we're doing. The blue is a color typically associated with cool, low energy, right? So that's kind of the blue part, and the mind is the brain-inspired architecture, the brain-inspired nature of our technology. So that's the meaning.
Our audience should be aware that you are talking to us on the day of tapeout.
Yes.
So running on caffeine, I imagine. So that's something that's really cool. And this isn't your first chip that you've taped out either. And so
That's
you've
correct.
gone way beyond theory. We've got tell us
Yes.
about the current chip that you're taping out.
The worst thing you want to do is be building a solution looking for a problem. So having that customer input and having the validation of your technology as you go along is crucial. You cannot just work in isolation, developing your solution and hope that it's going to be solving problems for customers down the road. So we very deliberately took the approach of engaging very early with lead customers and building silicon test chips very early on. In fact, from the time we raised our first round of funding, we taped out our first chip within 6 months. And that's the chip we walked in the lab briefly before this interview. I showed that to you. That's the chip we built within 6 months. We built a second chip not long after that. And now, using those proof of concepts and prototypes, we engage deeper with our lead customer base. They started believing more that, oh, okay, this is not just PowerPoint. You're showing me real silicon, demonstrating what you claim you can do. That builds a ton of credibility. In our industry, it's all about showing silicon, right? You can't just talk about it. You got to show things working. So that allowed us then to engage these lead customers in a deeper way and actually get to product definition with the feature set, right? This is crucial. You got to have the feature definition really nailed down with customer input, because we cannot imagine all the use cases and all the features that will be valuable for people down the road. So you got to work with key customers, lighthouse customers, to do that. So we did all that, and we defined our first product, which is what we're taping out today. So yeah, that's been sort of the journey to get here.
If we're to fast forward a couple years
Yep.
and Blumind is successful, what impact do you believe you will have on society as a whole?
We hope, Justin, to have a very deep and lasting impact. As I said, we see us as a key enabler to push AI out to where we live and work, in our devices, in our gadgets, in our machines, in our robots. This is what we want to see. We want to enable more and more. So I think, and actually I think that the need is so big that it's not just going to be us. It's going to be other companies, other technologies as well. There's a lot of great work happening around the world in this space, more and more. So there will be a few technologies that will enable this, and we intend to be one of the big players here.
Well, and you mentioned that there's, I think last count, somewhere roughly around 210 hardware companies focusing on
Yeah.
AI acceleration. So if you were to, in summary statement, very, very briefly say why Blumind's different, what differentiates Blumind, what would you say?
The key thing, Justin, is our technology enables orders of magnitude better efficiency, performance, latency, and cost compared to solutions on the market today. And we see ourselves as being highly differentiated from anything else out there. So we have a significant moat against other competing technologies. So this is really what makes us different. But getting to the root cause of why we have this differentiation, it really comes down to our team. Our team is a phenomenal mix of those three disciplines: data science, device physics, and analog mixed signal design, sub-threshold, high precision design. These are skill sets very rare to find, and we have a blast working on this stuff. So
you talk about team, and so you're on the third iteration of the chip. Assuming that that's successful, scaling the team is going to be important. What are the challenges you foresee in scaling the team and growing the team?
yeah, it's a good question, and I can't claim to have all the answers to this, but we definitely see a shortage, especially for folks with deep analog design knowledge, semiconductor, like I said, high precision, sub-threshold design. These are skills that have gotten increasingly scarce in the industry, and it's a bit disheartening for me that a lot of kids going into university are not picking these fields as much anymore, right? So we are trying to contribute to changing that, right? We hire interns every semester into our team, and kind of ignite the interest and make them aware that there's all this great innovation happening in the semiconductor industry at the moment. So working with our academic partners, I mean, we're blessed here in Canada. We have some amazing world-class universities and organizations that are helping drive this change. But I think it's going to come down to, hey, we got to get kids interested, firstly aware of the space again, and then interested in working in it. And I think that's going to happen.
What do you see the future growth of Blumind looking like in the next 6, 12, 18 months?
You know, the big order of business for us right now is getting this first product chip into the hands of our customers, making sure they love it and they commit to deploying it into, you know, multitude of applications. So that's going to be the big drive for us the next 6 to 12 months. Beyond that, we have a pretty well-defined roadmap in terms of increasing the capability and scale of our chips to do larger workloads in the computer vision space and well beyond that as well. So the team is going to be working aggressively to develop those products as well.
You mentioned getting the product, the chip into the customer hands.
Yeah.
Right now, what's the one problem or one situation you're looking at that keeps you up at night?
Getting customers to appreciate our value proposition because we're a very different solution. That is the big challenge. Getting them to adopt, or not even adopt, but commit to validating and evaluating our solution first and putting it on their benchmark list. That's the big push right now. And you know, these things, being a startup, we move really quickly, but our customers are typically multi-billion-dollar companies that move very slowly. So that process always ends up taking longer than you anticipate. So we're doing everything we can to lower the bar, the barriers to adopting our product. Our software stack is greatly simplified. We make it very easy for folks to train their networks and their data sets on our silicon and just evaluate and deploy our solutions. So that's the main push and you know, one of the things we're constantly working at. Also, because we're a startup, and we're early, right? This is the first time we're going to market, so this is a lot of new stuff happening in this space. So this is a major focus for us.
Have you guys thought about or considered making your software open source?
Yeah, we have, and certainly once we get our first generation device, we want to make this as accessible to folks. We want to have people optimize things as much as they want to, right? So we will benefit from that, and absolutely, there's no reason for us to not make it open source. Our secret sauce, if you will, is our chips, right? Yeah. Our implementation is really what creates the solution. So everything outside of that, we absolutely want the community to participate and benefit.
Good. That's something that we've seen be successful, and I think that's another differentiation between what you guys are doing is that you're not shying away from or running away from the fact that the hardware is your secret sauce and that the physics behind it. And because a lot of companies anymore are their secret sauce is software,
right?
And so I think that may make it an additional layer of challenge getting the adoption with customers. No,
because this is a fledgling market, right? It's emerging now. Even customers don't really know what machine learning can do for their applications yet, right? They themselves, they don't have machine learning teams. Okay, if I'm a smart device manufacturer in China or India or wherever, maybe I've been doing things a certain way using microcontrollers and you know, sequential code. That served me well for now, but now, okay, how do I use AI? I have nobody on my team that knows machine learning. So our customers are also in this state of discovery, right? Yeah. And trying to figure out what they want to do. And herein there's a little bit of a chicken and egg, right? So the semiconductor industry, also the big guys that have built multi-billion-dollar businesses around these processors and other components, they don't know what the customers want. In many cases, the customers themselves don't know what they want to do. So we're in a little bit of a deadlock situation where the industry is not moving because they're like, well, my customer's not asking for this capability, so I don't want to invest in it. And the customers are like, well, I don't know what AI can do and how low power you can get, so I'm concerned about deploying it. So we're trying to break that deadlock situation and come in and say, guys, here are chips that are actually working. They bring your power down 100-fold or more. What does this unlock, right? And more we're finding some customers, the more innovative, forward-looking ones, coming up and saying, oh, wow, that's really cool. That will allow me to differentiate my products, so I'll take a leap and take that with you guys. So that's the dynamic in the industry right now. It's the case in all new markets and new applications, right? But I feel once the industry and the customer base sees more of these proof points, there'll be an avalanche of folks jumping in.
Well, and you mentioned a moment ago that just the three of you on the leadership team have a combined 70 years of experience, and that's one of the reasons why A, I was so excited to talk to you, and B, I'm getting behind what you guys are doing, is because you do have that experience. So many founders and executives of hardware and software companies, frankly, haven't seen a product go to market.
Right.
And so that's a distinct advantage that you have. How has your past experience led to the patience necessary to be successful here?
Yeah, it's Justin, I think that's a very key point because the semiconductor industry is extremely unforgiving, right? There's huge amounts of capital needed. Your time to revenue is long, especially if you're building an innovative brand new product like us. It's 3 to 5 years until you actually get this in customers' hands, right? And ramp up volume. So it requires a discipline to see your technology development, your productization, your customer engagement, all of these aspects of the business through in the right way without running out of cash, right? Being a startup and deploying your precious capital and talent in the right way. So there's very little room for mistakes here. If you have a bad tapeout, if your chip doesn't work, or you're unable to attract the right talent, or there's a million things that can go wrong, and because the capital needs are so large, it's very difficult to recover from these mistakes. So a lot of mistakes become fatal mistakes, which in the software, if you're building a SaaS company or so on, you have more opportunity to recover from those types of errors, right? So the experience definitely helps tremendously, and the dynamic in the team is really important. You gotta trust each other. You gotta work towards a common goal, and just maximize the efficiency of the limited resources that you have.
Yeah.
Right. So that's what the experience does for us, and it's been great actually. That's been one of my personal desires, is to work with a really experienced, seasoned team. So our decision-making process, while we don't, we disagree on many things, but on the high-level vision and execution, we're very, very well aligned because we've all lived, very similar experiences in this industry.
To touch on something you just mentioned there that's all important, running out of cash. If you were to speak to the investment community and lay out why they should invest in Blumind.
Right. Well, I think it starts from the opportunity. The opportunity is massive, right? That the market size for these products is going to be absolutely huge. I think within this decade, it's north of a $25 billion opportunity. And beyond that, I mean, there's a significant upside as well if there's some of these new use cases come online sooner than that. I see proliferation of AI in these edge devices growing exponentially over the next decade. So, and it's not me alone. This is a lot of industry analysts, a lot of other startups that are operating here, a lot of larger established companies as well. So that's certainly the big driver. Secondarily, I'll say I think investors need to understand that innovation has to go down, go across the stack, right? It cannot just be in software. And I think more and more investors are understanding this. You have to, there's this term deep tech that's needed, that's used for these foundational hard technologies. I think more and more investors should get comfortable with that because that's where a lot of value is being created today, right? With AI, I think the world has realized that you cannot just innovate on the software layers. You have to go deeper. You have to innovate at the silicon and develop these domain-specific architectures to really get the value out, right? So,
no, makes a lot of sense. And another thing you mentioned just a moment ago was hiring the right talent.
Yep.
As you are looking to scale, you cannot build a silicon company anymore. It's really building a hardware, software, co-development environment. A, have you guys thought about that? And B, it sounds like the three founders or the three leaders are all from the silicon side.
Yep.
So how do you plan on building a harmonious hardware, software, co-development organization?
It's crucial, Justin. I mean, the way I look at it is our customers are not chip people, right? They're buying a device and their interface into us is mainly software, right? They're training their neural networks. They want those networks to run on our device seamlessly and have no loss of accuracy, performance, and get this extraordinary energy efficiency. So we're very, very cognizant about that. Although we have a semiconductor background, we've run businesses that had similar dynamics with customers in the past. So building a strong customer and application layer is really, really important. We've had software folks on the team from day one. Some of our founding employees have deep embedded and machine learning expertise, and they've been with us from day one. So we've definitely not ignored that, and in fact, its prominence is going to increase going forward. So we're going to have more folks with those skill sets as we deploy these solutions and support our customers.
Awesome. Well, I've thoroughly enjoyed the conversation. I'm leaving here more excited about Blumind than when I came in. And if somebody, whether it be an investor, a potential employee, or a customer wanted to get a hold of you, how should they do that?
Yeah, our website's a great place to start. Blumind.ai. Please check it out. We are very active on LinkedIn as well. So reach out to us through both of those forums. We'd love to talk.
Excellent. Well, Niraj, thanks very much. And I would say goodbye, but until next time.
Wonderful. Thank you so much, Justin.
Thanks, Niraj.
Yeah, take care.